Hello, Mr. Eric, Mr. Ryan, right? We are given two array of digits, single digits from 0 to 9. Contains the unique digits from 0 to 9.
It looks like Onyx. Onyx or Egypt.
We want to find out the minimum number. We want to find out the minimum number that contains the digit, contains at least one digit from both arrays. So from smallest mean number contains one digit, at least one digit from both arrays, okay?
So you can't do 12 because you can pick both of them from A.
No, look here, 12, you can do 1, 2. This is one choice.
Yeah, you said we can't do 12.
No, 12 is not a minimum because I can just pick 2.
Yeah, that's 22.
Okay, I want to form that uses the digit. So I can just form, I can just say I want to 2.
Yeah,
And
you can't get
the first array has 2, the second array has 2.
So that makes 22.
That makes so you can do 1. You can do 12.
I can do 12, yes,
Yeah.
12 is a valid answer, but not the smallest answer. 22, yes, 22, but I can just use 2.
Yeah, but
I'm not picking, I'm just saying I need to come up with a number that
but 2
appears
only
in...
appears in one array, and you have to pick from both arrays.
Yeah.
It's a bit confusing, right?
But 22, but 2 is not valid answer since there's 2 2's.
And you said you have to make a 2-digit number.
No, I'm not saying 2 digit
Yes,
number.
you did.
Okay, I did.
Yeah, you said it before. You're
Okay,
like,
okay.
oh, you have to make a 2-digit number.
Yeah, but I corrected, I cut it out. So from a minimum number.
You didn't cut it out, you know that.
Yeah, okay.
You said it in front of the.
Makes sense now?
Sort of. If there are no numbers in each one erase.
If all of A if all of A and all of B are the same number, like if all of A is 2 and all of B is 2.
Yes, what do you call it? If
Two
no,
hundred
unique.
222.
Yeah, but 2 and 2 is not unique.
No. These numbers in one array is unique.
If there are no numbers in any of the arrays. What if there are no numbers in any of the arrays?
He means if there's no numbers in any of the arrays.
Good question. Yeah, no. It's raining.
It's raining tadpoles
Out of the sky.
What do you mean by form?
Form to
How do you like form?
form. What is the meaning of form or digit?
Like
I'm going to close my
make.
window.
Construct the digit.
I'm going to close my window.
Okay.
Yeah, but then like make. Yeah. But
Yeah, make it. Yeah.
How do you make like 22 into 2? Yeah, how do you make 22 into 2?
You can pick one digit from each. Right?
Yes, you can.
Yeah, that's one way.
The 2
Or you can pick a digit that appears in both arrays. Okay. Now, is it clear now?
Is that the only way?
There are two ways.
Is that the only difference that you can pick 2 digits from both 2 and only pick one which appears twice?
That's right.
That's
Yes,
the
perfect.
Is that the
That's-
only difference?
Yeah, we can think of it this way. If a number has appeared in both arrays, we can just pick that single number, which is the smallest, obviously, right?
It's not the smallest, obviously, because if the 5 was a 1. If the
Yeah, I was going to say that. Then you pick one instead of 2, right?
Yeah.
Okay, that's good. If no numbers appears in both arrays, then what do we do? What's our strategy? Ryan, are you right?
I think you like merge it and then you sort it and then you pick the smallest number. Like one time you told us like how to get it from 2 get to this, like you give us a list of numbers.
Yeah.
You give us a list of numbers and then you pick 2 to make a number which is the smallest, and so we kind of do that. So we merge the 2 arrays and then you sort it and then you pick the first 2 numbers.
Okay, so merge it.
Yeah.
If there are no common paths, no intersection, okay? 4, 8, 9. Okay, so what's the smallest number we can form?
14.
Yeah. So what's the strategy?
So I merge it in. So I think
You merge it. Then you merge it, it becomes
We
1,
sort
2,
it.
3,
We sort it.
4, 8, 9.
We sort it.
yeah, that's sorting. Yeah.
Yeah,
Yeah. I want to like sort it and merge it. I'm not sure which order, but anyway, I will do that. You know how you gave one lesson, you gave us a number, like a big number, like and with digits, and then you and say like the bucket thing, you jump, and then jump, and we need to create two of the smallest two numbers, which creates the minimum sum. And you said it like the bucket thing, like ooh. And we're doing something like that. So the first two numbers is 1 and 2. So we pick 1 and 2. The smallest number is 1, so it goes first. And the second numbers have to be 2.
We need to sort it.
Sort is 1, so it's 1,
Sort.
2, 3.
And
Sort
then-
is 1, this is 4, 8, 9.
And then
The
the
smallest
first
number
twos.
is this one and this one, right?
Yeah.
And then is it 1, 4 or 4, 1?
1, 4.
Yeah, so we have to make a check, right?
Yeah.
Okay. Okay, so to sum up, two cases. If one number appears in both array, we just pick the smallest. If not, then we need to get the minimum of each one, right? For example, if the
What
minimum
if
is
one of the arrays is empty and the other is not?
that's a good question, but the requirement is that we're given two non-empty unique array, okay?
No, the question said given two arrays of unique digits, nums 1 and nums 2, return the smallest number that contains at least one digit from each array.
Yeah, okay. So how do we find the common part of both arrays?
Set.
Yes. Okay, so look
Oh.
at what's this?
That's a Venn diagram.
Venn diagram. Wow, that's a good memory. We talked about
It's
that
a
in
block.
day 3, day 4.
I didn't
Yeah.
learn it from you. I learned it from school.
I know this from my
Really? You learning this from school?
Yeah,
Okay. Venn diagram,
of
yeah.
course we do.
In math?
I think I
You
learned.
need the A after the I in diagram.
Okay.
No, A after the I in diagram. No, after I.
Yeah.
Diagram, okay. Okay,
You need
so
to remove A from the
here is
Venn.
A,
Yeah,
here is B.
die
So
A.
here, this part is A and B, right? Intersection, right? This is the common part, right?
Well, can you do like a numerate?
Not really. Enumerate is more like listing the values one by one, right?
Yeah, but you need an index and a value, and you can see how
We
much.
don't need an index. Why do we need an index? Okay, so look, we can just do this. Define F, A, B, right? Two array. So C equals set. We turn the A into the set and set B, right? Turning the list to set and do the and intersection, or we can say set A dot intersection set B.
I'm fishing the teeth.
Teeth, not tooth.
Yeah. If we have C, if we have a common part, we want to do what? If we have common part, like if there's a
We want to pick the smallest in that common part.
yeah, so we return the minimum, right, of C, am I? The common part. Does it make sense?
Yes,
Alternatively, we can sort it, right? But obviously, we don't need to sort it because we just need to get the minimum part. Otherwise, if this is the situation, A is here, B is here, A is disjoint with B, so what do we do with
no,
that?
or you can have a Venn diagram with nothing in it.
But if this is the case, what do we do? If the both sets are disjoint, we don't have a common part.
We do
So
We do the maths.
we solve the A and we solve the B.
do we need to sort the A? What do we do? Why do we need to sort the A? What's the purpose of sorting?
So you can't get the smallest number.
Yeah, we just want the smallest number, so why do we need to sort? Like sorting will be O and log n, right? And then this is sort, right? Dot sort. But if we want to get the minimum and maximum, we can just use the minimum and maximum. That's O n, right? Which one is better?
O T. Okay.
O n, right? Do you know how to get the maximum, for example? Get the minimum, for example, like 2, 1, 3, 4. How do we get the minimum?
So you put 2 and record it as the
Minimum.
minimum, and then 1 minimum, and then you go to 3 and you still put 1 in minimum and 1 in
Yeah, that's right. In one go, right? In one go. That's O n, right?
Yeah.
Okay, color minimum 2, color minimum 1, color minimum 1, color minimum 1. Am I right? Yeah?
Yeah.
But for sorting, you need to do this merge sort, quick sort, and make this list to 1,
It's
2,
coming.
3, 4, right? And then we get the first one, right? This is O n log n. But this one pass is O n. Okay, so we just have to say
I'm fishing.
minimum A is min A, right? Using this function. Okay, minimum B equals min B.
We put the smallest out of minimum A and minimum B in the
Yeah, I know. Now min A and min B, for example, min A is 1, min B is 4.
Yeah, I'm saying that if you compare minimum A with minimum B, which is 1 and 4,
Yeah.
minimum A is minimum than minimum B. So you put the minimum A in front of the minimum B.
Okay, so you say if MA is smaller than MB, then we return MA times 10 plus MB. AS return MB times 10 plus MA, am I right?
Yeah.
How many choice? How many kind of choice? There's just 2, right?
Yeah.
So one choice is MA times 10 plus B. The other choice is
MB times 10
plus
A.
A. Okay, and we want to get a
Minimum.
minimum. Does it make sense?
Yes, of course it does.
Do you have to put else after MA times 10 plus B? Because it's a return.
Mean, the mean function, right? Return mean. MA times 10 plus B is 14. MB times 10 plus A is 1. The function returns 14. This is the same thing as if MA is smaller than MB, return this. Otherwise, we return this. How do you implement this mean function? Just given 2 numbers. I want to return the minimum of it. If A smaller or equal than B, return
Return A.
A as return B, right? Or you can just say return B, right? Same thing. Yeah. Okay. Another way is that MA and B, I can say return. I want to return the minimum MA and MB times 10 plus MA and MB. What function should I put here? Minimum MA and MB, which is 1, right? 1 times 10 plus.
Max.
Okay, this is another way. Does it make sense? Another way of writing it. This is the same thing as here. What have you done? What's the problem? How do we solve this?
We got 2 arrays of digits, integers, from 0 to 9, and you want to find the minimum number you can make, the smallest number you can make by 1 digit. That has to be at least 1 digit, and you can, by using, you can use that min function, blah blah blah, and just go for each one and find the minimum number on each array, and then the max, and then we need to find the smallest number in each of those, and then put that at the front, and then the number at the back, and then you're done.
Oh, so yeah. So today we learned about this thing that we have 2 arrays A and B, which have to be non-empty, and so they contain 1 digit integers, which are 0 to 9. So and then you want to find the smallest. You want to form the smallest number by picking 2 numbers from each. No, at least one number from each array. If there's in the array they have to be in unique digits, and if they're duplicate numbers that A and B share in common, then you can just return that single digit.
In common, there could be many multiple common parts, right?
Yeah, you return the smallest common part.
Yeah. Okay.
And then
Keep going.
and then if there isn't, and then you just find the smallest from A times 10, and then plus the
Sorry to the-
smallest from B.
Yeah.
And then
Okay, there are two ways, right? Think about, okay, yeah. What's the time complexity? It's quite tricky here.
N million.
What's that?
N is a number.
Oh, and are you sure? Okay.
No.
N is N.
O-N.
Okay, let me get it.
A
A and B contains the 2 unique digits.
N is
You-
the digits.
How many unique digits you can have for one array?
Lot. Well, no,
Huh?
9.
10. Yeah, okay, so what's 10?
9.
0 to 9.
0 to 9, yeah, what's that?
O1.
N.
1 constant, because the maximum number is for both array is 10, just 10 numbers, right? So we are solving the problem with confined space, right? So it's just 10 numbers, no matter what you did. 01, right? 01, 01, 01, 01, 01, 01, 01. Even this mean, converting to set. Usually ON, right? But A and B is just 10 maximum numbers, right? 10 numbers, so it's 01. So the C, at most 10 numbers, common part. Finding a smallest number in 10 numbers. How many iterations you need to do? At most 10, right? 10 is a constant number, so it's 01.
What will we do
Make sense?
next lesson?
I don't know. Good question.
Well, is it that? Are you doing one of those questions? It said on the computer since it's accepted.
Okay, maybe yeah, we can try. Okay, thank you.
Which are minimum time to eat all grains, escape a large weight, maximum number of integers to choose from an array to, and add minimum numbers of rounds.
Good idea. Okay, thank you. Bye bye.